I don't know what, I hope all of us know what you call the reconnaissance survey. Hello?
Yeah.
Just continue. Just continue.
A reconnaissance survey. That is the first part of survey that the engineer, the surveyor, and the host community. You go for a reconnaissance survey. In the aspect is that you go there, you study the nature of the place, study the topography of the place, you get a detailed report of the area or the particular place the road is being located. Then from there, you now come out what they call a recce report. That is like an inception report for the project of your embarking on. So that report will encompass what they call the hydrological analysis. You have your own hydrological analysis, detailed topographical survey of the area, the soil type of that area, and all the general, how would I call it, entities associated with a detailed recce report. So from there now, you are done. The surveyor will now go to site and gather what they call a detailed topographical survey of that area, be it any infra work you are doing. So the detailed topographical survey is the starting point for any infra work or road work or all that you are working on. So that topographical survey is when the surveyor will now go with the instrument, be it a differential GPS or a total station. Will now go set out at TBMs, start picking out points along the corridor you're working on or the environment you're working on. So after the surveyor has been done with that now, then you will now give that point to the engineer. So the engineer now, the civil engineer or the highway engineer will now come up with the detailed geometric design of the road to meet the required road class you are designing for, be it a federal road, a state road, or a rural road. So basically, from this slide, you can see road selection and design depends on what? The nature of the subgrade, the traffic and drainage condition, the construction time available, equipment, personnel, and expertise available. So let me also go to this geometric design. The geometric design begins, just like I was saying, the geometric design aspect of it, which just has to do with the vertical, the horizontal, and the cross section as well. So the geometric design begins with a good topographical survey. This aspect, the surveyor will go to the site, and you, the engineer, will now instruct the surveyor that, surveyor, give me a detailed topographical survey of this area I'm working on. Let's assume we're working on a project of about 2 kilometers, and I want a surveyor to give me a data for that 2 kilometer road. I will tell you, so on my road width, proposed road width for my road, let's say is 7 meters. I will tell the surveyor to give me at least from the center point of the road, left and right, letting me 15 meters. So why am I looking at 15 meters? That is at every 5 meters, it gives me 3 points. 3 points. So along horizontal, it's giving me 5 points. And you take that 5 point down straight to the end point of the road. Why am I looking at that point? If you go to a site and a surveyor, and you instruct a surveyor should do a detailed topographical survey for you, and you just went and do the work anyhow. When you are doing your earthwork computation, see that you have a shortfall in your earthwork computation when carrying out the earthwork computation. So they say it's better you ask the surveyor to at least 20 meters both side and right, let him give you data and goes down to the end. So the design process can be described in the following step. Draw the proposed center line on the topography survey, draw the center line, the plan of profile, calculate the grades, the degree of curvature of horizontal curves, curve length, and vertical curves. Then the fourth one, is compare the 3 steps with the road specifications. So these road specifications is being detailed here on what do they call it, on Federal Highway Manual. I don't know whether we have. You go to Federal Highway Manual, which is this. For the this one is a geometric design. So from at this manual, 2013 Federal Highway Manual, this is where all the, how would I call it, the parameters that will guide you when you're designing a road for a particular road class, like the federal road, state road, rural roads and all. So these parameters will guide you now. This federal highway manual will guide you when you're designing. Like let's assume if I'm designing a road for federal road now, and I'm how would I call it? I'm using this elevation of 8%. So the federal highway manual will guide me on parameters to use, the minimum parameters to use for like 8% super elevation, like this now. So for federal roads, the maximum design speed you use is 100 kilometers per hour. I think for state road and rural road, you can use 60 kilometers per hour. Then for all these our normal estate road and all, you can go below 15, 20, 30 kilometers per hour for design speed. So that design speed is being controlled by the super elevation to assign on that road. So for federal roads now, the maximum super elevation prescribed here in the manual is 8%. So if I'm using 8% super elevation for my road now, to design my road now, and I'm using a design speed of 100 kilometers per hour, which is this one here now, you can see it here on the screen. So this is 100, this is 8%. So when calculating for my radius of that curve for the road, the minimum radius I'm to attain is this. If I'm falling short of this 394 that is stated here, and I design my road for that particular curve, and I put 100 kilometers per hour, and I'm driving as I'm approaching the road, and I'm, what would I call it, below 100 kilometers per hour, and at that curve, I'm supposed to meet a curve radius of 394, which is the minimum. And I'm driving at a speed of 100 kilometers per hour. On approaching that curve, if the curve is below the standard here stated here now, that's what will now imply what they call a TSM drawing, a TSM, traffic management system drawing. This if for the curve to be less than this 394, which is stated here for 8%, it means that at that particular region, let's assume I'm having a built-up area at that region now. So for me to navigate my curve along that built-up area, and the government insists they're not going to pay for compensation and all. So to navigate my curve along that built-up area, I will now introduce what they call a traffic management system design for that particular curve. So what that means is that I will now be bringing my signage before and after the curve. I will now bring what they call speed bumps before and after the curve, so that the driver is driving on that road, since my design speed is at 100 kilometers per hour, and at that particular radius, that particular curve, I'm below this specified radius. Let's say which is 394 for 8% super elevation. So I will now introduce what they call design speed limit before and after the curve, like 100 meters before and 100 meters after the curve. And put the signage and put the speed that the driver will use in navigating around the curve. So I'm just giving a detailed summary of what we'll be doing. So I'll go through the slides now to present this one. So let's just start with this now. So we have this design of road infrastructure. So classification of roads. We have federal ownership, federal highways, state roads, local roads, and rural road. So we have class A, the class B, the class C, and the class D. So the class A is a normal federal roads that connects to roads. Class B, from the terms at state road. Class C are rural roads, linking all those are rural roads, linking our market and more. Then class C are rural minor road within the district as well. So classification of road by ASHTO. We have this one as well. We have freeways, we have arterial roads, other freeways, and we have collector roads as well. So factors influencing the classification are the trip purpose, trip length, the size and type of population center, the traffic characteristics, and the network system. So all these things I'm reading now, I just extracted them from the federal highway. So for class A road now, the instructor stated that the annual daily traffic with more than 20% heavy vehicles. But we're expecting 15,000. So for you to have a class A road now, they have the federal highwayman have stated they've done some research and come up with the annual daily traffic for a particular road. That's why you see the minimum carriageway for a federal highway road is 7.3 meter for a single carriageway. So if they've anticipated that the numbers of traffics that will ply the road should not be more than at least 15,000 vehicles per day. Then you can see the minimum design speed, 100 kilometers per hour. Then class A2 will have annual daily traffic of 20,000 vehicles per day. An average travel distance on links indicated by major trips being less than 2 hours in duration. This one too is 100 kilometers per hour for the design speed. Then we have class B. This is between 8,000 to 10,000 vehicles per day. So the minimum design speed is 80 kilometers per hour as well. Then class C, so 80 kilometers per hour as well. Then class C3, minimum design speed there is 500 vehicles per day, 60 kilometers per hour. So this design speed for a class A road, for a class A, which is a federal road, if you are designing for a class A road now, I'm designing for a class A road, my design speed, I should assume, is 100 kilometers per hour. For class B, which is state road, those ones should be 80 kilometers per hour. Then for class C, which is also a rural roads, design speed maximum 60 kilometers per hour. Then class D, minor access road, the ones entering our street and all, 40 kilometers per hour design speed. So these are the speed we'll be assuming when we're designing our distance. For a class A road now, I'm designing a road from between two states, connecting two states. I use 800 kilometers per hour, federal roads. Then interstate, 80. Then rural roads, those are leading to our farms, and was 60 kilometers per hour. Then the minor ones on our streets, 40 kilometers per hour. So we apply this design speed when we go into the usage of the software proper. You see the effects of the design speed. That if you put a particular design speed, and you've custom that to be 60 kilometers per hour, and you put 60 kilometers per hour, and you go below the radius to give you like a flag sign showing that there's something wrong here. That is just the radius, the K values, and all is below the design speed specified. So once we go into the software, we see the effect of design speed and all roads. So these are just picture showing our roadways. This one is a class A road. This one is a rural road. This one as well, and this one is a rural road. You can see road types now. In freeways and urban areas, where you have freeways and urban areas, design speed specified by the federal highway manual, you should use 100 kilometers per hour. For freeways and expressway in rural areas, there is a freeways. We have freeway, no beat up here and all around the vicinity. You can still go as well as 80 between 80 to 100 kilometer per hour as a design speed. Then in an expressway in urban areas, 80 to 110 kilometer per hour as a design speed. Then for conventional road, like rural road, where we have flat terrain, as a flat terrain, you can use between 80 to 100 kilometer per hour. Rolling terrain, 80 to 100. Then in mountainous terrain, 60 to 80. And urban areas, where you have arterial streets, like the streets we're having, streets, 60 to 80. Then arterial street with extensive development. You can see this development where you have much built up area. So design speed specified from the federal highway manual between 40 to 60 kilometer per hour. So if you are driving above this speed, it's not advisable. The effect of this design speed is being felt on our when we are navigating our course on our road, our horizontal curves, and as well on the vertical curve. If I design a road for 40 kilometers per hour, and you are driving that at a speed of 100 kilometers per hour, when approaching that horizontal curve, and that curve is designed using 40 kilometers per hour, and the driver mistakenly use 100 kilometers per hour to navigate that curve, that driver is going to go out of the road because the speed he's using approaching the curve is more than the design speed used in designing for that curve. So that is when you're driving on the road now, you're approaching some areas where you have where you have the curves that are not that sharp enough. You must match your brake to that speed so that you can navigate along the horizontal curve. But if you still stick with the speed you are applying on a straight tangent, to just take you out of the road. By causing take you out of the road. So most of the time, this design speed are being fed on curves. On a tangent, you can drive 100, this. But once you're approaching a curve, you fed the impact of that design speed will be fed. Because if you go above the speed used in design for that particular road, your vehicle will just take out of the road and go to the bush and all. So it's good we know when we're designing for federal roads, we're using 100, rural 60 to 80, then other urban rural 40 to 60. So those are the speed. So these are vehicular design for a particular road class or buses. So this is traffic flow. Some we don't do traffic analysis. Our traffic HT, the number of vehicles passing a particular point on a road in 1 hour. The daily traffic, the total number of vehicles passing at a point on a road in 24 hours. The average daily traffic, on average of daily traffic passing on the point on the road over the duration of at least 7 days. The monthly average daily traffic, an average number of vehicles passing the point on the road each day for a month. An annual is the average daily traffic passing the point on the road over 365 days. So this daily traffic and all, if I'm designing for a road, now for a rural road, which they've specified and carried out analysis on, if I'm designing for a road that has, what I call it, more traffic coming on that road, so I'll be looking at making my road width to be more. If it's a place that the traffic volume is less, so my road will be less. That's why I say most times on our rural roads, our village road, most times the width of the carriage is not more than 6 meters because the traffic Flying that road maybe vehicles per day maybe like 100, 6 meters, some 5 meters, because vehicles flying that road is the traffic volume is less compared to the urban areas. That's why the starting point prescribed for the federal road, as stated on the federal manual, should be carriage of 7.3, which can accommodate, based on researches which have been carried out on law, can accommodate the average daily traffic and the annual daily traffic as well. It can accommodate more vehicles. So I see in most of our estates environment, most times their roads are normally width of carriageway on most of the estates. Sometimes some use 4 meters, 5 meters, because the traffic volume is also small. You enter your house, park, and goes out. But in an areas where you have more traffic volume behind the roads, you see that the width of the road will be more expanded. So these are the factors that necessitate when, as in when you want to carry out your road design as well. So you go and run a traffic analysis of that place and to know the number of vehicles passing that place daily and all. Then you now propose the actual width that can accommodate the traffic flow. That kind, if the road is being designed and that properly and it is being designed, they propose a carriageway that can carry the traffic volume on the road. These are classes of vehicles. We have motor, light vehicle, or then passengers and so that's the classes. Then geometric design. A branch of highway engineering concerns with the position of physical element of road according to standards. The basic objectives in geometric design is to optimize efficiency and safety with minimizing cost and environmental damage. Geometric design. It's also designing rules to foster border community goals and all. So this geometric design is the aspect that we're working on now. Highway. If prevention surveyor, if she goes to sites and pick detailed topographic survey and not sent to you, the engineer, you now will not be the one to carry out the geometric design, the vertical, horizontal alignment of the road to meet the required class of the particular road you are designing for. So these are some of the parameters when we are designing. We'll be considering the passing, stopping sites, decision site, and all. These parameters we consider when we are doing our design. You can see minimum stopping site distance. For a design speed of 50 km/h stated here, you are stopping a minimum 65, passing 345. What it means is that if I'm driving at the speed of 50 km/h, and my minimum side distance for stopping, I want to navigate along the road, I should be able to see 65 meters ahead of me. Then if I want to overtake, I should have 745 meters clear of me before I overtake a vehicle. So those ones will consider them as well when I'm designing for the horizontal alignment. So these ones are the grades. Stopping side grades and all. Once you're using them, you see the effect. So these are the components of geometric alignment. So this particular one you're seeing here, the area view of the road. If you go up and take a drone and snap across the area view, as that is the horizontal alignment. Then once you cut a section and once you see them doing on the road, pushing lateral and all that, trying to prepare the vertical alignment of the road. And the horizontal is the one you see there. It's the area view of the road you see. The vertical is also your cut and feed. The vertical alignment of the road. So you have alignment, profile, and cross section. So these are alignments. And this is the profile here, which we will apply when we're going to the into usage of the software. This is a typical cross section of the road now. The alignment is the route of the road that defines a series of horizontal tangents and curves. So that is alignment. The profile is the vertical aspect of the road, including the crest and circles, the straight gradient lines connecting them. Then the cross section shows the shoulders, curbs, median, roadside, slopes, ditch, sidewalks, and drainages. But those are a typical cross section. Also, I'm showing the horizontal alignment now. The alignment shows you the vertical and the horizontal curves of the road. And the profile shows you your sag and crest curve of the road. And the cross section shows the lanes, normal lane, two side lane, two lane, the curbs, that is the median, the shoulder, the right side, slopes, ditch, sidewalks, and drainage. So the typical cross section drawing will show you the detail. It's like the road furniture of that, the furniture of that road. The profile will show crest and sag curves and the grades. The alignment, which is horizontal, will show you horizontal curves and the tangent length. So you can see the design codes. So design code standard, the code procedure, as stated in the, what do you call it? The Federal Highway Manual. And this is your horizontal curves. Horizontal alignment is a further feature of the road design. That is the one we see. The vertical, as I explained, is the, what would they call it, the cut and feed has been on the road, the earthwork. So horizontal alignment consists of straight sections of road known as tangents. So where we're having the straight section of the road is called tangents, connected by a circular curve. We have different types of curve. We have the transition curves, circular curve, the reverse curve on the road. So we have different types of curve. So circular curve are divided by radius, tightness, deflection angle. The design of a horizontal curve entails the determination of minimum radius based on the speed limit, curve length, the object obstructing the viewer of the driver. So
hello, sir.
Yeah.
Engineer Victor, good morning, sir.
Good morning.
Yes, sir. Have we shared the material for the class today?
That's what, and what you say is going to share it. It's going to give to you guys today. It's between.
Okay.
Yes.
All right.
So there is a Google Drive you shared on WhatsApp group. I don't know whether it's the material because I can't access it.
I'll get back to Nyauchi and confirm.
That one is not opening. I don't think it's the correct link. So it's not opening.
Okay. I will get back to him and I'll confirm for him to reshare it back. So these are those formulas in school. Those formulas are no. This one, if you're radius, your curve, and all. So all this has been, like I stated, all these are what will guide us when we're doing our design for horizontal alignment for the curves. You can see if I'm using a design speed of 50 and it's for elevation of 4%, so I'm expected to have a curve of the minimum radius 86. I can go above that, but minimum should be 86. But if I'm driving at 50 km/h, I can navigate that curve of 50 km/h design speed. So for 60, we have this 70. So these are where, if you go through the Federal Highway Manual, they were explained and stated there in details.
Please, sir, this table, sir, please, that table that you just gave an illustration, this maximum F, what is F?
F is the coefficient of slide. I'm going there, you see it here. Coefficient of slide friction. E is for elevation. V, design speed. Then R is the minimum radius in meters. So this is the formula. That is the formula that they compute and they got all this. So for 50, spallation of 4, F, then this formula, then the radius, then radius. So they inputted this formula now. What do they call it? This particular formula here to get the radius. E or F and all. So they inputted the formula to get the radius. So you can see now, based on the Federal Highway Manual, you can see what the restricted us to. For rural roads now, you can see here, they're giving us a range that to use for our design, elevation. For rural roads, you should use between 5% to 6% super elevation. So if I'm designing for rural road now, don't know what people know about ramp. You know about new ramp projects. Mostly ramp projects are normally rural roads. It's a World Bank project. So they expect you, if you're designing for a ramp project, you should use maximum super elevation speed, super elevation of between 5 to 6%. It shouldn't be more than that. Then for high speed urban roads, it's between 4 to 6%. Then for minor urban roads, so it's between 2 to 6%. So if I'm designing for a rural road now, let's say I want to work on a project now, and I'm designing for a rural road now. For rural road, the maximum design speed is 60 kilometers per hour. So I'll be restricting myself now to where is the table? To 60 kilometers per hour to its elevation of 6%. So from there now, I will now get the minimum radius to apply for my horizontal curve on that alignment for rural roads. Then for high speed urban roads now, you can see 4% to 6%. Then minor urban roads 2 to 4%. So these are the first criteria you input when you are in your design. You design speed first. Then the next one is for elevation. Put this maximum for elevation. Then after that one, then the software will now plot the software will now calculate the curves automatic. Then you now go and see where the curve is having a shortfall based on the standard on the manual. Now increase the curve. But just like I explained earlier on, if it's an area that's a built-up area, and you're having that curve between two, and the built-up area is close to the road, and the government or the agency said they're not ready to pay for compensation, so you just find a way and navigate around the road along that curve. But once I navigate along that curve, so once I'm done with the design, we now provide what they call those road signage on our drawings. So you now provide them the starting point of a road, the signage will be there to caution the driver the maximum design speed 60 kilometers per hour. So when it's approaching a curve that is below that design standard, set that's below that radius, that is 60 kilometers and navigate. And let's say we're having a lesser radius. So at that point, and the driver can navigate at, let's say, 40 kilometers per hour, and your starting point of design was 60 kilometers per hour. So before the curve, like I think it's 100 meters or 80 meters before the curve, and after the curve, you put that signage there, 40, 40. So the driver will be conscious that as he's going forward, he's supposed to reduce his speed from 60 to 40. So if he's not as well that conscious of that signage, that's when you now see them introduce what they call speed bumps on our road. So we put speed bumps before and after the curve. So the driver to slow down his speed, not navigate after and before and after the curve. I will now go. Once you go out of the curve, then you can now continue with the required speed. So the centrifugal force is step by weight of component vehicle. So it's just for elevation. And these ones are the elevation rate curves, and these ones are explained on the highway manual. And research for them as well. So this one are the speed, maximum related gradients, and all. So this gradient now, maximum gradients. Let's go down. Let me go down. So let's see. So these are the vertical curve parameters. You can see design of horizontal alignment, steeple, reverse circular curve, compound circular curves. So we have so this is the PC. This is the point of curve, point of tangent, and point. So the software will calculate all these parameters for you. Once you input, you just put the point of curve, point of tangent, and give you the curve length, the tangent length, the length of curve, all this curve length, everything. It will be automatic for you. So these are the horizontal curve parameters. Those two formulas we use to induce this in school to calculate for your curve length, deflection angle, length of this tangent length, and node. So this is a transition curve. You can see transition curve between two circular curves. You have a transition curve. So the transition curve. Most times, most people designs normally used to avoid it. But in situation where you have a terrain like that, you just put it like that. So the transition curve is a horizontal curve. is a total curve of various radius, which is used to connect straight line to connect to a circular curve. So that's areas where you can't do without, you put it like that, you put them like that. You just flow the element like that. So the next one is the conditions of transition curves. These ones are those materials and details. We can research. It's stated on the highway manual. If you have the federal highway manual, you read them in detail. These things are, I'll just crop them from there. They are well explained there. Those are the conditions of transition curves as well. Widening, alignment, all these are. No. Then these are the design split, flat, rolling, and all. So profile. So this is a vertical. You can see a vertical curve there. This is not showing you now. This is a vertical, it's sack curve. You're driving across the road, goes down, and you go up. There's a vertical. Then the crest is as if you're climbing a hill. You can see for me it's a crest. Another one is a sack curve. So those are the two types of vertical curve we have. So as well, for a vertical curve and a sack curve, design speed as well controls the design speed controls it as well. This says that there's what we call K value, the length of curve. You have the minimum K value for 50 km per hour using a 6% super elevation, 100 km per hour using 8% super elevation. So those things will be shown when we're using the software. You see them based on the ASH2 standard, which the Federal Highway Manual was derived from. So we have those K values. Those K values now control what we call our passing and our stopping side distance as well. If I'm climbing a hill, like I'm driving, I'm climbing a hill on a vertical curve, a crest vertical curve, and I design that road for 60 km per hour, and I'm not seeing a vehicle. I don't like call it a vehicle coming, and I'm climbing in and I want to overtake. So this K value is what we get. That K value now, if the K value meets the required criteria, and I'm using the required speed for that particular road, there's no other person coming, and that person coming using the 60, me coming using the 60, that will collide. Because we're not seeing ourselves. There's no way we'll collide. There's a way we can navigate each other without colliding. But if I'm using this speed of 100 and I design a road for 60, and I'm climbing the crest curve, I'm trying to overtake without seeing a vehicle coming from the other side, that's why you see that collision happening and we have that accident, because you have gone above the speed limit designed for that particular crest curve. And the K value there as well. So once you are overtaking, now you're using 100, that person is using 60 to come. That person using 60 might navigate. You trying to navigate, you might fall off or hit on that thing. But that person using 60 can have that leverage to dodge, to avoid that collision. For you that are using 100, there's no other, you won't collide with the other person. So those are the things we'll go. Once we're using them, you see them in practical, once we're using the software. So these are the profiles showing the SAG, and that's the typical road, showing your SAG and your crest.
Sorry, Engineer Victor. That's the standard where you need to see the next vehicle coming from up your side view. So, sorry, what's that standard distance?
The standard
Distance where you need to see the next person coming from your crest, where you have that side view, so
Side
that you not
distance,
collide.
side distance, minimum side distance.
Yes.
for 60, I think it's about 260 something meters, 265 meters. You're supposed to have a clear view of the vehicle coming. But if you are climbing a crest, that's why I see them. That's when now traffic management system drawing is now coming to play here as well.
Engineer Victor, should be minimum side distance. Hello?
Yes, that's what I mean.
It's in the highway manual also. The minimum side distance depends on the speed, is 150. Like you said, most things depend on the design speed of the road. The design speed of the road is one parameter that determines a lot of factors. But the
Yes,
minimum
yes.
site distance is about 150 for about 80 kilometers per hour. So it now depends on what speed that you are designing for, but it's in the highway manual, and we'll share it after the class.
All right,
Thank you.
noted.
So, like, if you are climbing a crest curve now, you see that they will now introduce what they call traffic management system drawing on our road as well. The broken lines on your road shows you can overtake. But when you see a line that is thick and that is not broken, shows you should not overtake. So you see those on those crest side, those hilly areas, you see those lines, they're normally not broken lines. So the driver is supposed to be conscious that at that point you're not supposed to navigate and overtake a vehicle. But if you're overtaking it, if peradventure you want to overtake a vehicle at that hilly area now, that's why you need to maintain what they call the design speed for that particular road. Because that design speed will guide you a lot if you're overtaking. And you should be conscious as well. The other person coming from the left-hand side, is he as well sticking to the design speed as well? If he's not sticking to the design speed as well, that's when that collision now comes into play. That's why it's not always advisable to overtake on a crest curve. Because you're climbing here, you're not seeing the other vehicle coming. So the types of vertical curves, we have the crest and the sag vertical curve. So these are the crest, then the sag, then the K values. You can see the K values. The definition of another vertical curve. So these vertical curves are being controlled by K values. Based on federal highway manual, the minimum K value for a sag and a crest curve should be 45. The K values, that is the length of the curve divided by A. So it should be 45. And as well, the wider your curve, if I'm climbing a crest curve now, if the curve at that crest curve is a bit, what they call it, it's wider, I will be able to see a clearer view of a vehicle coming. But if it's shorter, then I'm not able to see the vehicle. So I have to ensure that the minimum length of curve is met, and the K value as well is met for that particular curve when I'm climbing a crest. That's why you see them now doing what they call cut and fill. At the hilly area, they will cut to have that maximum side distance of a vehicle coming. Minimum, at least you can see a vehicle as I climb the hill. So these are the things that controls for the crest and the sag. So if we go into software paper, we'll see the usage and the importance of the K values and the length of curve, the vertical curve. So this is the crest curve. These are those the calculations and all. So these are the formulas we use in calculating the K values and also these are star curves. That's true. Star curve parameters as the K values. Those formulas extracted from the highway code. This one as well is a graph. I'll guide you as well. Where to part. So those are examples to calculating your length of curve, K values on your star curves. So these are let's now go to the cross section. Element of a cross section of a road. You can see the paved surface, the camber, curbs, width of carriageway, road margins, width of formation, shoulders, drainage, and all. So these are the typical cross section of a road now. So if you are done designing a road now, the client will not give the specification, or you might have done what the client will not give the specification. This is what I want on this road now. I want this typical cross section of a road. I want the two-side drainage. I want this. I want this. So this is when now all those things you'll be learning for the class periods will now come into play now. If I'm designing for a road now, I will not do my storm analysis and to know the actual size of the drainage that we can cater for the runoff water coming on the runoff water coming from the paved surface. I'll do the sizes. I'll design for them, do the size, analyze, and get the size of the drainage that will cater for the runoff, the rainfall, runoff water coming at that particular point I'm analyzing for. So these are those the cross-section of a road, traffic lane, traffic lane, shoulder, roadway, element of a cross section. You can see them, the roadway, the shoulder, the median. These are those the veg. This is a typical complete cross section of a road. We have the traffic lane, 2 traffic lanes, shoulder. We have the side drain. We have the slope for cutting. We have the bend. We have the slope for cutting. We have cut-off drain. Then we have veg in our road. So these are those the typical cross section of a road. So these ones are the cross slope for a road. So you can see that specify for a Portland semi-concrete, your cross slope should be 2.5% cross slope. For a bituminous mix, there is a paved surface between 2 to 3%. For a penetration treated earth or gravel, the cross slope should be between 2.5 to 3%. Therefore, on soft grade sections, 2.5 to 3%. So what it means is this 2.5 to 3% is the camber of the road. So once the rain drops, you can camp the road now. The water will now flow both way, 2.5%, 2.5% both way, flow downward to the drainage. So you can camber your road one side, 2 sides, and all. So that's you can see for a concrete as in a rigid pavement, a paved surface 2.5. This one 2.0 to 3 for bituminous. Then for earth or gravel road, 2.5 to 3%. Then for graded sections, 2.5 to 3% as well. What this cross slope does is that if peradventure let's say you're done with your design now, and you are having, what do they call it, a cross slope of less than 2.5%, the movement of the water on that pavement will be slow. So you see that there's some water retention. Once it rains and it rains on our pavement, the movement will be slow, the water will be retained. But that's why anywhere you see that there's the water, what do they call it? Water being retained on the pavement. These criteria are not met. When they were doing the earthwork and they're laying the asphalt and all, they didn't actually do the surveyor didn't properly take a proper level in considering this 2.5% camber on the road. So that's why some places water, you see water gathering on the road, which is bad. And in more distance time, they will have some seepage of water now lead to all these alligator cracks and all on the road. So the road will start giving way. So all these criteria need to be met as well. As well for our vertical alignment, the gradient of our road, the minimum gradient you can have when you're designing a road now, that is your cut and fill, your profile of your road, should be the minimum grade should not be less than 0.3%. If you create the road design for me now, let's say I'm a consultant or I'm someone I want to vet your design now, to checkmate your design of what you've done. Just like how we do for structure and all. What I'll be looking at? I'll be looking at your K values. 1, the gradient of your road. 2, the curve parameters of your road. 3, and what do they call it as well? The length of your tangent and all of your road. So for a paved surface, if you're having a gradient less than 0.3, the design needs to be flagged. Supposed to have the gradient supposed to be minimum 0.3 to maximum 8%, 6%, depending on the vehicles that are plying on that road. Like now, if let's say Abuja is busy like this, some areas in Abuja, and I know that we'll have tippers plying that road more. I can't design that road to have a gradient more than 5%, 4%. Because if having a gradient of more than 4% or 5% or 8%, the thickness of that road will be more. So if a trailer is climbing that road now, and is applying his brake climbing that road, there's every tendency that tipper can slide back and fall and come back down. So those are the things we'll be looking at for the gradient. That's why I see them when they're designing, you see them doing cut and fill. They're trying to get the gradient they also like to meet up based on what the design they've done, to meet up with those gradients. The 0.3%,
Engineer, sorry. The gradient you're talking about, is it the vertical? Are you talking about vertical alignment or the camber of the road?
Vertical alignment of the road, the vertical alignment
All
of
right,
the road.
thank you. Thank you.
The
Thank
cut
you.
and fill. The minimum should be 0.3% for a paved surface. So what it means that if I have 0.3% now of my road now, and it rains, and that as water is moving, I'm having a camber of 2.5%. That water will drain faster from the road and go to the drain. But if I'm having a gradient of below 0.3%, let's say 0.02, the movement of the water will be slow, and the camber by 2%, but the movement of the water along the stretch will be slow, and the water will be going gradually. So the minimum you have to meet is 0.3 for the gradient, then the camber 2.5. So the water will move faster and go out of the road faster. So once we're going through that, once we're going through the software, I will explain all the things that we've been saying. We see them in usage. So these are the elements of a road cross section. You can see your cuts. These are your cut and fill. Or you have a height of, you can see this one, undivided mountain lane, a height of between 0 to 3 meters. Or you have in a height of cut of 0 to 1.5. You can cut in 1 to 4 slope. So these ones are the cut section for, if you're having a high field, when you have to cut, you cut between 1 to 2 slope. You cut in, what do they call it? You cut, whether you cut in benches or you cut with the direct slope that comes down and trapped by, what do they call it? Trapped with that drain at the toe of the embankment. So, element, the same thing as well. That guides your cut and filling when you are cutting on your road. Having high fill, high cuts and all. So you use the minimum what the slope you use 4 to 1, 1 to 2, 1 to 3 and all. So this will guide you when you're doing that. So elements as well. Fill and all the traffic. So that was the typical crossing of the road, showing your veg and all. These are the typical crossing of the road. Now you can see showing your carriageway, 3.65, 2.5 shoulder, no steeper than this and all. So desirable for slope section. So you can see the camber. This is showing 3% here now. 3% there. For the shoulders, the cambers are normally between 5%. So what it means is that if my carriageway itself is having 2.5% and the water is going out on the road, so at that shoulder point, the camber is normally steeper, so the water will move faster on the shoulder because most times our shoulders are normally surface dressed. So water will move faster from the shoulder and go to the drain. Sometimes we use edge drain as well. What do they call it? Surface dress on our shoulders. Most times, especially when the project is when a lot of money they paved completely, they do wearing binder on the shoulder, but most times they use surface dressing on the edge of our shoulders. So all these are those parameters that I explained. So if he shares the federal manual to us, we can go there and also do further research and study and research about all the terminologies here. So medium barrier, all these things are also the cross section of the road. What is ones intersections of the road? There's just an area shaded by business. So intersections, when you have two roads colliding, you know the intersection you provide for and all and so factors to be considered when you're considering ones are stated on the highway manual, just the ones that cropped out. So if the highway manual is being shared, we can do further research and study on all these parameters I'm brushing on the screen. So road intersections and you can see types of intersection we're having. C, right angle, oblique, offset, so on Y intersections. So the various intersections we're having, we can have on our highway. So it's a whole picture showing them. So these are the crossroad. You can see the items, the channel island, intersection angle, cross median, exit ramp, those parameters for intersection. Typical intersection showing the typical road and traffic flow, showing the traffic flow. Like this sign showing the traffic flow, the movement of the vehicle. This goes, this and all. The arrow signs and all. The dotted lines. So these are showing the island, the median, and all, channel island, of intersections and all. So this one is the T. So we have various types of intersections. So you can as well do further research and study more on them. So basically, this is what we'll be in the next 3 weeks. This is what we're applying them using Civil 3D, all the parameters. So these are interchange on our road. So there's interchange and all. So types of interchange, you can see them as well. Trumpets, clover, direction and all. So interchanging on road as well. That's where interchange, directional interchange. These are road ramps.
Hello,
on
sir.
road. Yeah. Okay, yeah.
Please, yes, sir. Maybe at the end of the class, you give time for question, Abi.
Yes.
Okay.
So this ones I'm not sharing is just a slide and all. So I want to go proper now into the main business. So are those materials extracted from the highway manual, which I stated that should be shared, and we can also do further coding and research on it. So these are those. So if you are done.
Hello. It seems we lost Engineer Victor. Regards to your question, I think today is the introductory day for this road design, and today is more like a foundation class. Every material you see will be shared with you. The highway manual will be shared with you. I think we've already shared 1 and 2 for the drain, for the IDF. So what we need to share now is 2 and 4, 1 and 4. So we've shared 2 and 3 or so. So it will be shared with you. Unfortunately, I tried to look for at our cloud whether I will see the material, but I couldn't find it since we have deleted it. That's why the link is not opening. So after the class, you're going to get all the materials, and I will encourage us. This is a new area for a lot of people, and it's something that we need to find time and go through. Find time after now and go through it and study the background, so that by next week we'll know that we are entering the computer application straight on. That will really help in this class. Once we enter that computer application, let it be that everybody already knows the basics. Engineer Victor, when you are back, you let me know. Status here. Okay, let me pause the recording. Hello, Engineer Victor.
Hello? Can you hear me? Okay. Hello?
Yeah, continue.
Okay. So basically, as I was saying, before you proceed in any road design or any infra works project, you have to do what they call an inception report or a recce report. They call it a reconnaissance survey report or an inception report. So that report will form the basis of the design embarking on. So what that report will entail is that it's going to cover one, the what do they call it, the hydrological survey of the hydrological report, the what do they call it, the geographical report of that area, the soil report, and the soil properties located on that area, and if possible the rivers and all the details incorporated that way guide you when you're doing your design. When you have rivers, when you have the soil, from there you will determine the soil properties along the corridor, where you can have a close by borrow pit, where you can do what you have your materials for your construction, you do your source for where you have your close by quarry, and you can have all those entities that will aid your design, aid you when you are carrying out, when you are done with the design as well, and the payment, when you're planning your payment for the road as well.
Engineer Victor, Engineer, please then let's do a little freestyling. Because this has reminded me so much. I did in photo. Knife loading of this of a road, or axle loading. To be able to get the maximum knife loading. Right now in the highway manual, is it given in block, or that this primary elementary way of doing knife loading?
Like for Federal Highway Manual now, they've done their research that they've come up with, just like I was saying, that annual daily traffic. They've done the research and come up with a carriageway of minimum carriageway for a federal road should be 7.3 meters, 3.6, 3.6. Then that axial loading you're talking about, that's where that axial loading now will now come when you are doing your pavement structure, pavement analysis design. That's now comes when you are doing your subgrade, your sub-base, base course, the wearing, and the asphalt. So that's axial loading they are talking about. They will know what they all like call the vehicles that apply that route. So based on what they've done on highway matter, they specify that the minimum thickness for all their from the subgrade to the finished level should be 500 mm. That is 50 cm thickness. Your base cost 200. Your sub base 200. The base 200. Then what do they call it? The wearing and binder 40-40, 60-40. So based on what I've done, but if you are going to a project and you know that you have a higher axial load coming on that load, and you anticipated that a lot of the vehicles coming there will be, what will I call it? Be heavy duty vehicles. So you have to do what they call pavement analysis, and you design using the axial load to design for the particular pavement together with your soil parameters, which are the CBR and all. You have done your soil parameter analysis to come up with a thickness that can accommodate that traffic coming, that can withstand that traffic coming on the road. So, but the federal highway they have done the research and known and come up with, at least based on the one we have in most of our roads, they propose minimum 500 mm thickness can accommodate for any axial load lying in front of the road.
Yes, you're right. Now there's a review of the road construction materials. The minister right now is trying to make it permanent that the highways, federal highways, are rigid pavements.
Okay.
Reinforced rigid pavements.
Yeah.
Yes, that's what's going on now. So the advantage and disadvantage of the rigid pavement with respect to the flexible pavement.
You see, sir?
I think it's best we continue with the class. We can, after the class, we'll have a question and answer session. Let's focus on this foundation we are laying and go through the highway manual, go through the basics, lay the foundation for this training. And then after the class, we'll have a FAQ session. Victor, hasten up. We've done 1 hour. Give the whole basics, and then maybe we'll introduce the software.
Okay, no problem. It's okay.
We've
So
done 1 hour. Introduce the basic. We'll send them the material. They will read it up later.
okay, it's okay. So from there now, after the survey, the surveyor will now will now come up with your reports and all things. So that will now form the base of your design. From there, you now proceed and start with the proper design, which we will now be going into. This is our slide now. The next slide. Was 3D road design. So this is a AutoCAD Civil 3D user interface enhances the standard AutoCAD environment with additional tools for creating and managing civil design information. Standard AutoCAD features such as command line and all around campus, and it's a BMI software which we are conversant with. It's a very good tool for infra works and all, and it does the computation and the design automatically and faster. So basically, this is how the user interface looks like. Civil 3D is like what would I call it? It's like normal AutoCAD interface, which are all conversant with and we all know. So this particular area you're seeing here now is your work area. So it's your work area. You can see it's stated there, our work area. Then this one, the next one is the quick access toolbar, which is located here. Quick access toolbar. The next one here is on the item is the ribbons and the workspace. So this is the ribbons here. All of these are the ribbons from here. Are the ribbons. In our workspace, if you put your cursor here now, you can see it's displayed here workspace. So what this workspace means is that if you have Civil 3D on your software and you decide not to have any AutoCAD, how would I call AutoCAD? Civil 3D is a software that comes in a complete suite. It has AutoCAD embedded in it. It has Civil 3D. So if I want to go to an AutoCAD workspace environment to do my drafting and all, I will just come to this my workspace here now. If I come here, click here, I will switch it to drafting annotation. So I'm on AutoCAD interface now. I will do my work, all my drafting and all on AutoCAD interface. So if you have Civil 3 at times, it's not sometimes most people that have Civil 3 in their software, they don't normally install AutoCAD because it comes as a complete suite. You have Civil 3, the road aspect, you have the AutoCAD aspect as well. So you can do your drafting and annotation work on this one. So if you want to go back to Civil 3D interface, now we'll come back to this workspace here now. Now we'll go back to Civil 3D. So to take me to the road aspect, the workspace work road aspect, having all these parameters on my ribbon. So the next one now is two space. So this two space, what this two space entails is it's like if you're using your structural software you're using, it's what they call tree structure attached to any structural software. So if you import a beam, you're working on a beam or a column, you can go to that place, switch and off layers and all. This is what the two space stands for as well. If you come to this idea now, this is my two space. So if peradventure I've imported the points, you see to create an icon for me here. At this point, you see a box and attach here showing that I've created a point. Then if I've created a surface to show as well, I've created a surface. So anything I'm working on, like any item I create, it's just like AutoCAD will have layer properties in AutoCAD where you can switch and off layers. So that's what this two space does in AutoCAD Civil 3D. You switch your layers as well. You can switch your point group layers, surface layer, alignment layer. You can switch them on and off and work on other entities. So it's the function of these two space here. These entities. Yeah, point group, points of and all. That's the function of the two space. So once we start using them now, you see the effect of all these entities here. So the next one is So these are the interface. These are those interface. These are my ribbons. This is my tool space. It's my home tab, insert, annotate, those normal interface. And these are my workspace area. This is my quick access toolbar. And if you're comfortable with AutoCAD as well, you can. It's the same approach. So these are my palettes. These are my create ground data panel, point, surface, transverse. Here we have parcel, feature line, and grading. So are the design panels. So these are the entities I'm using for my design. For alignments, intersection, assemblies, pipe network, corridor, and all. These are my profiles and sections. So when I'm doing my profiles, the vertical, I'm using this, and my cross section as well, making use of this. So the next point of corner, we'll go into the tools now proper. Tools. So the first thing we're looking at is points. Points. So point AutoCAD Civil 3D object that can be displayed in a drawing and manipulated graphically. Point appearance is control using point labels and point style. So what are these points? These points now are the points that the surveyor, once the surveyor have gone to the site and they have carried out a detailed topographical survey of the area. So these points are the points that now the surveyor will now send, extract it from the differential GPS and all, and now send to the engineer, the highway engineer, or the civil engineer that will carry out the design in an Excel format. So what are points? The points now, the point will come in 4 formats. So the format this is the format the surveyor will give to you. The point will come like this. This will have we have what they call P. We have what they call E. We have what they call N. And we have what they call Z.
Somebody so mute now. Engineer, mute them if they're disturbing the meeting.
If even at December 29, you won't buy at the same price. Sorry.
So the P now, this P represents what they call point number. Point number. Then the E is what they call easting. The N represents what we call northing. Then the Z, that is the elevation. Elevation. So these are the 3 entities that the surveyor goes to the site and pick with their differential GPS or total station, anyone using. So they will go, you see them going along the road, picking, using the differential GPS and picking points along the road. So they are picking the first thing that the major entities that are picking up, that are looking at is the easterning, the northing, and the elevation. So this easterning, northing, and elevation are the 3 entities that we use, that are the major parameters that we use when we're doing our design. If parameter is where we go to side and picks wrong coordinate, or a wrong coordinate and all, it's going to affect the design. Once you go back in doing your setting out to affect what they call it, the setting out of that particular road. It's going to take you from different information. So how do you know when the surveyor is doing the right, is doing what do they call it? When he's working on a project and you want to checkmate him. Like now there's a tool. You can use Google Earth or use GIS as well to do this one. GIS. So basically, if you're supposed to go to the side, in Nigeria, we have 2 datums that we normally work with. We have the MINA datum, and we have WGS editor, World Geodetic System, WGS 84. So those are the 2 datums that the surveyor, that once they set up the instrument now, and they want to plot and set up and start picking points. So they either set it in MINA or in WGS 84, World Geodetic System. Those are what they call it, the projection we are in this part of the world. Whether they use Mina or they use WS84 in setting that data. So if peradventure a surveyor goes to the site and he didn't establish the right coordinate and all, he didn't do a proper setting out of his instruments and all, and once they plot the road, they will actually pick that particular location that you want them to pick. But once you are done designing and setting out, once they go for setback now, you see that it's taking them a distance away from that road. So the surveyor needs to, as the engineer, as well, you need to carry the surveyor along that, okay, this is what you have to work with. If you're working with this, let me know the datum you're working with. And what is that datum? What datum means is the high difference from where we are standing. Like now, if I'm standing somewhere, where they put out a typo stand, the difference from that place to the sea level is the elevation. The high difference from there to the sea level, to the sea. That's why I say in this part of the world, if you're in the north, the far north, the elevation difference are normally high. If you are going down to the south, Bayelsa, or you see that you have an elevation difference of a lower because you are closer to the sea level, the Z is normally high in the area of some areas in the north. If you go down to the south, Bayelsa, Kwaibom, Kala, all those areas, the elevation is normally lower because they are now closer to the sea level. That's the Z, the height from that place relating to the sea level. So the surveyor now will work on a projection, which we have in Nigeria. I think we have 4 projections. We have the zone 32, we have zone 33, I think we have zone 34, 31, 32, 33. So if a surveyor is working, if a surveyor is working at, what do they call it now? Say he's working from Abuja now, Abuja, Benue, Niger, Kaduna, Kestina, all those sides, all are zone 32. So the surveyor will need to do a proper setting out and programming of his instrument to suit the particular area he's working in. He's working. If he's working somewhere in all this, what they call it, the southwestern part of Nigeria now, Lagos, Ondo, and all that, are all in zone 31. Then this other region, the 2 zone 33 we have is in, I think it's in Adamawa and Maiduguri, some part of Adamawa and Maiduguri, and zone 3, zone 33. So he's going to do a proper projection and setting out of that particular area he wants to capture his data before he proceeds in capturing his data. So the 3 data is the way we'll be giving to you is the eastening, the northening, and the elevation. So those are the 3 parameters that we need basically in our design. The point number now is just on your Excel workbook now. Point number 1, 2, 3, 4. As you're speaking the point now, you're numbering them. Point 1, point 2, point 3. So those are the point number. The eastening, the northening, and the elevation. Then the last one is what we call, another term they call it again, D. Most times, some surveyors don't normally put this D on their data if it's a virgin land. Most times they don't put it. So this D means description. What it means is that if a surveyor is going for a survey now, he has established his TBMs, that's a temporary benchmark on site, and his starting point from the 0, he's starting from the 0 and start picking his coordinates. Left, right, center. From the center, he picks the first point. He goes 3 meters to the right, picks. 3 meters to the left, picks. 3 meters on that peak. Then he comes back to the left, 3 meters. Let's say he picks 18-meter stretch of point and start going down like that. So once he picks that point, if it's like a bit of area now, as he's going now, once he picks that point, and you're having an entity there that will guide, that the designer needs to be aware of, he's going to bring a description for that entity. So what that description will stand for is that, like, let's say he's picking a point at this point and he's going, and having a building point there, a building located there, he's going to put BD. So that building represents building. You see them on the, like, say, BD building. Once he goes from, I see transformer, TR, transformer. Once he goes front and you see along the project corridor, electric pole, EP, electric pole. So he's going to give you a description of the entities peak that he encountered along the corridor when he was picking his points. So that's what the description stands for. So this description as well will aid you. If peradventure you didn't go for what they call the reconnaissance survey with them, this description as well will aid you to know what is along the project corridor. So when you are designing your horizontal alignments, you know how you navigate and make sure they don't, in case of building, there's no, you avoid the demolition of buildings, or you have electric poles, you know the number of electric poles that you locate. You have a transformer, you know the transformer you locate, or you have a river crossing, you know that there's a river there at that point. So the description will guide you on, the description will be established on site, will still guide you as well. If peradventure you didn't go for the collision survey with them, with him. So the history now, nothing, elevation, and description. So these are the entities that guides us when we are doing our design. So these are what they call points. These are the points we're looking at for. That is why we sent to you in this format. Look with points. Let me share a point with you now. Okay, data. Let's use this. So this is what I'm saying. So this first entity I see here now is the point number. Point number 1, 2, 3, 4, 5, 6, 7. This is the point number. Then this one now is the eastern. This is the northern. This is the elevation. And this is the raw description, the description of the entity. So the question might come up now. How do I know which of these two? Which one is the eastern and which one is the northern in the data the surveyor sends to me? Because there's a format in which the softwares accept this, accept the Excel workbook if you're importing it into the software. So that's where now the question will not come now. How do I know which of these two entities here now? Which is the eastern and which is the northern? Most times, a surveyor can send you a data like this, and there will be a header like this. It will be insert. It will give you we will say P, E, N, Z, and D. It might give you a header description of the entities. But sometimes, some of them might not also send data like that without giving you the header to describe what they call the entities there. So how do you know which one is the eastern and northern? In all your survey data, most times, the higher one between these two, is the northern. The lower one is the eastern. You need to be conscious of that. The higher one, higher between these two values. The highest number, the higher value is the northern, and the lower one is the eastern. So that's how we know to the northern and the eastern value. It's very important. It's very, very important if we're importing our points into the software. It's very important we take note of these two entities. So now, from there now, if the server has given you the data, you have converted, you've seen the eastern, you've seen the northern, you've seen the elevation, you've seen all these entities there. So from there now, the next thing you know, say, okay, let me check now the format in which the surveyor sends me the data. How is the format relating? So in Civil 3D, we have various formats of importing data into the software. The formatter, this is the first one I just did here. We have what they call PenZ. PenZ, that is PENZD. This is the first one. The other one now is this one now. We have PNEZD. So you have to be conversant to know which of the two comes first when the surveyor sends you data. Because if peradventure, a surveyor sends you data and the northern comes first before the eastern, and you import your data using this PENZD, this thing will take you to a different location. You take you to a different, or let's call it coordinate, because this coordinate now is like a georeference coordinate on ground. So you're importing into the software, working like in an environment that is georeference already. So if you're done working now, you go back to start to set out, it just give you a different location. That location is working, that location is established. So you have to ensure to know, most times what they do is that they change these two entities. they navigate between the both of them when they send you the Excel, the data extracted from their artificial GPS. So first you need to check which one comes first, either the easting or the northing. Just like I said, the northing is always higher than the easting. So that's the criteria you check once they send you data. Once they check, okay, this okay, this is okay, this is a northing, this is easting. So you now know the format you'll be using when you're importing your data into Civil 3D. So we have the first one, PENZD. This is the first one. This is the second one. We have another format again. We have PENZ. We have PNEZ. So what this one is this PENZ or PNEZ. What this one entails, like if it's supposed to go to the site, now that is a virgin land you want to just establish. So it's not going to have any description on that land. Let's say there's no river crossing and all on that particular land. It's just going to give you data of PENZ, no description, no D. Mostly this PENZD normally comes in areas that are built up area. That description will come in. They want to do a road development for a built up area that there's no road for this. So that D will come in. Or if it's a virgin area, that D is a virgin land, that D normally to be PENZ, PNEZ. So my emphasis now is for us to be confident of these two guys. So I said, the northern and the eastern, which one comes first on our column, on our Excel workbook? Either the northern comes first or the eastern comes first. So if you're not conversant with all, what do you call it? You know the northern, you know the eastern. And I've emphasized it, the northern is the highest value between the two of them. It's normally higher than the eastern. If you check the value and check which one is higher. It's the northern. So if you're done with this and you're conversant with the next step, the next thing now is, if you're supposed to send you data now, the next thing now is for 3D. How is this format? How is the Excel workbook being accepted into Civil 3D? How do we call in the format into Civil 3D? There's a format that we will save in Excel, which they follow me. The format is called CSV. CSV, comma, delimited. So if it's supposed to send you a data now, it might send it just in an Excel workbook like this. But most times, the data they extract from the virtual GPS, most times they save it in the CSV, comma, delimited. Or if for adventure, you didn't save the format in the CSV, comma, delimited, just say something like this. This one I'm doing, I save the CSV, comma, delimited. You can see what this entity here is showing. We're showing book 1 Excel. But what the previous one I copied from? It's showing what? JFCon Excel, CSV Excel. So it's showing that I've saved this particular data now in a CSV format. But this one now, the other one is just showing book 1 is Excel. It doesn't have an extension file name attached to it. But this one, if I want to save this one now, this one will save in an normal Excel file extension file format, same format, XLX for Excel. So the first point of call now, the next point of call I will do now is that I will go to this place, I'll go to file here now. Then I'll click on Save As. So when you save as now, look for where a folder, or I might start to save on my desktop. Let me save it on my desktop. So on this desktop now, I will now give this file name. Let me name this file 21 TR1 21. So on this my save as type, now showing Excel workbook XLXX. So I will come here and look for what they call CSV, comma, delimited. I will go through and look for CSV, comma, delimited. So see it here. So I will save it in a CSV, comma, delimited file format. So I'll click this. So you can see it's now the save as file name. Now you now click save. It must be a question. You can see now it has not changed to tr1.csv Excel. So I've now saved it in a CSV, comma, delimited. So from the next stage now, we're now going to my software now. And now carry out the first two, which is importation of points into Civil 3D. So it's a points are AutoCAD Civil 3D objects that can be displayed in the drawing and manipulated graphically. Point appearance is controlled using point labels and point style. So the appearance of a point is controlled using point labels. So the next point of corner, I will now go and import the points into Civil 3D. So I'll go into the Civil 3D interface now. So if I'm on this interface now, the first thing I'll be looking at, I'm looking at the entity called points. The name, I want to import points. So the first thing I'll look for the name. Let's say I'm working on points now. I want to import my point. I'll look for the name, import points. So you can see, let's go to our home tab now. Right here. We come to create ground data panel. So you can see the first thing here is points. I have points here. I come to my two space here. I have an entity name called point here again. I have 1, 2. So the last one is the one that is not showing on here. It's not showing. There's supposed to be one showing on my menu bar. So I'll come to this my quick access toolbar here now, which I illustrated earlier on. I'll come here and I'll go to show menu bar. So I click on show menu bar, it will be displayed. So you can see now, if I have now file, edit, view, insert, general, survey, and I have points here. I'm having 1, 2, 3. 3 names points. So I want to import my point now. So the entity I'll be looking for is what? Points. So what I want to do, I want to show you 3 methods of import, 3 methods that you can use in importing your points into a Civil 3D working environment. So the first one now is this one here now. I'll come to points here. I'll say point creation 2. And I'll come to you can see it has bring out a dialog box showing create points. So I'll go to the last icon here. I'll click import points. Now this the dialog box will now be displayed showing the import points dialog box. This is the first format. The next one now, I will come to this two space, this point here. I'll select this point. I will right click and say create. It takes me back to that same dialog box, create points. I will now come to this last icon and say import points. So it brings me back to the same dialog box again. So the last one now is this menu bar which I just which I just call out now. I made it to be displayed on the screen. I will go to this point here. And I'll come to import and export. And I'll say import points. So I'm having 3 approach that I can use to call in my points. So the first one I illustrated earlier on was I went to points here on my home tab, create ground data panel here. And I went to points. And I click on point creation 2. And I click on the last icon here, import points. The other one is the points on the 2 space. I right clicked and I say create. And I went to this last icon here, import point as well. So the last one is the menu bar, which I showed on the screen, which I made to be displayed on the screen by going to this place here and say show menu bar. You know, it's showing hide menu bar. But previously it was showing show menu bar. So I went to point here now, and I say import and export point, and I click on import point. So to take me to this, all the whole approach will take you to this place that has a dialog box. So the next point of corner is this dialog box that has been displayed now. So now we have specified 5 formats for filtering off. So these 5 formats are the formats which I just explained using these entities here. These ones here. I have pen Z. I have the one that the listening comes first before the noting. I have the one that the noting comes first before the listening. I have the one that has no description. I have the one that has description. So this, I will now show you the 5 formats now here now. So the 5 formats are, you can see the first one, we have E, N, Z. What does it stand for now? Comma delimited. If it's supposed to send you data that has only listening, noting, and elevation, you select this format to match with the format you are calling into the software. Let's say I come to this side here now, and I selected the wrong format now. Let's say this. Let me also select this work I did now. Click open. You can see it showed an error sign because it's not matching with the format I started working with. So you select the format that matches with this. Let's say this is the format now. Just give me these 3 entities here now. So I will select that format now, ENZ. So I will select this first format. The next one is space delimited. NEZ, comma delimited. If you give a data that has nothing, you can see now it has not been interchanged. The nothing now comes first before this thing. This one, the previous one, this thing comes first before the nothing. This one now, the nothing is not coming first before this thing. So you need to know the format. Once it's going to send you data, as I explained earlier, you need to know these 2 entities, which one comes first. And I said earlier on that the nothing is always higher than the listening. So the next one you can see we have PENZ, comma delimited. So the point number, listening, nothing, elevation Z. So these are the formats. PENZD. So this one is having the description now, comma delimited as well. So these are the various formats. So what it means is that you need to know the format that the data is being arranged on your workbook. So once you are bringing in the software, you match to be on you match the format and that to be on the, so that the format you are calling in and the format you are matching, they will be on the same page. You will now synchronize perfectly well and sit on the software. So now, if I'm done with this now, the next point of contact, I said, I want to bring in my point now. Select files. So you see this plus sign we're having here now. This plus sign we're having here. I will now click add files now to locate where my file is being saved. If I click this plus sign now, I'll now look for where my file is, the data or the data I want to import. So this is the data I want to import here now. This is TR1CXV. I click this now. So peradventure, if you are using the software for the first time, you're launching for the first time, you've not used it before, you see this file name here. If you come to this side here to show like this, to show all files like this, so your CSV file format won't be displayed. You can see on my desktop. So you need to come back here and change it to what? CSV. So to now locate all the areas your CSV files are being stored. So you can see it's not displayed here now. I will now select this and I'll now click open. So once I click open, you can see it's showing me an error sign. So this error sign that I showed, I did it deliberately for it to show an error sign. So this now brings me to point importation, the challenges and the problems you may encounter when importing your point into Civil 3D. I will itemize them for you. There are three possible errors or three challenges you might encounter when importing your point if the point is not, how would I call it, the points are not being saved in the proper format and the points are not saved well. So the three challenges you have is one, you take note. If the Excel workbook is open and you try importing that data to show this error format for you, that is the first error you have. Like now, if you watch mine, it's open. I didn't close it. So if it's open, I try importing your point to show you this error format. No 0.5 format found. That is one. So let me close this now. Then this is my data. CR says one. So let's close. Let me close it and import again now. That's the first error. So I've closed it. So let me go back to my listing again. Repeat that same point. Importation now. I've brought to me all of us. So let me try and import that data as well again. If I come to this, if I click on this add sign now, and I go to this again and click open. See, it's still giving me an error sign again. But I've closed the workbook. Why am I saying encountering this error sign? This is another challenge now. This is another challenge, the second challenge that comes in. The first one is if the Excel workbook you're working on is open, to show an error sign. The second one, I've closed it, but it's still giving me the error sign. So what am I solving it? So this is where the second challenge now comes into play. I will now close this guy now. So I'll minimize and open. Let me minimize and open this and go to my desktop. So on my desktop now, this is my Excel, the one the work I saved. Shares the command later. So it's open now. So what caused the error now? When I opened and I tried importing, and my Excel workbook was closed. What caused the error was this guy here. The software is seeing that header as a different entity from those parameters that it's supposed to match, that it's supposed to synchronize with the format that is coming in. So you see this header as a different entity. So if a surveyor to send you a data and he imputes the header for you, showing you that this is P, this is E, this is N, this is Z, and this is D. The first thing you do, you have to ensure that header is deleted. Delete the header. Or you can copy this to a new. If you want to keep the previous one, and do Control A, Control C, Control N to a new workbook, and you paste it to Control V. So once you pasted this, then the next thing now, this header now, you take it off completely, delete it, and leave it like this. So you can now save this. Go to File, Save As, then go to Desktop. CSV comma delimited. Then I will give it a name. So then I'll click Save. So with this option now, let's try importing, what do you call it, our data into the software now. So the first point of call which I raised, I will have to ensure that this guy is closed. The Excel workbook is closed. So I'll close this. Then the second one, I will ensure that workbook I'm working on, the header was not displayed, which I've saved and I removed. I've removed the header. So the next thing, I will now go to the software now. I will now go to points. Ports. Now come. Then desktop. TR1, the new save that I just did now. Now click open. Watch now, they tick a good sign. So it has ticked a good sign, showing me that the point I'm trying to import, the format is matching with what I'm trying to call in, what I'm trying to bring in. So I will now come here now and specify the format that is having that is looking like what was on my Excel workbook, which was this format I stated. This format, if you come down now, you see this is the format here now. So you can see it will be displayed how it's been placed on the workbook. You can see I stated here now. This point number is name, not name, elevation and description. So you can see point number is name, not name, point elevation, and row description. So if peradventure now I choose the wrong format now, and I imported and I click OK to import into the work area, the point will be displayed. The point will be displayed, but I'll be working on a difference. I'll be working on an area that is not properly georeferenced on the work area I'm working on. So those two parameters that I stated earlier is very important: the easting and northing. Very important. So you can see this point has not been displayed because I closed the workbook and I removed the header. Then the third challenge you might encounter when importing your point, let me just rush and show that one now. You see, peradventure, a surveyor, most of these surveyors that still operate analog, how would I call it? I don't know how to use to extract this thing from the differential GPS. The data, and they want to use analog to start typing it. And they made a mistake when they were putting the typing. And peradventure, one of these data, instead of putting a dot sign, a dot, he mistakenly put a comma. That particular comma will disrupt you from importing. You will struggle, this thing coming from Mexico, why am I having this error? Why am I having this error? So, but the software will give that to hint you and take you up to that point where you have that error, that comma sign that he put instead of a dot. He made a typographical error. Instead of importing a dot, he put a comma sign in one of the data, one of the any of these points that has this dot sign. He put a comma sign. That does disrupt your work. Where is error coming from? Where is error coming from? So you'll be checking. So if these are the parameter there's a comma in one of the data, it will affect you from importing the point into Civil 3D. So but once you import, it will give an error that the file format is not found. You can now do a further check, and you see that, but this thing, I've removed the header. My Excel workbook is closed. But why is it my point not still importing? You have to try and check and do a finding, and you see that there's 1 point or 2 or 3 that has a comma sign instead of a dot. That disrupts the entire process of importing your data. So basically, these are the 3 challenges you might encounter when importing your points. 1, if the workbook is open, and you try importing, to show a conflict of interest that this is open somewhere. So you have to ensure that the Excel workbook is closed when you are done saving in a CSV, delimited. 2, if peradventure there's a header, there's a way to input a header showing that this is point number, this is easting, this is not this is Z, and this is description. You have to ensure that header is completely removed, deleted, then you save in CSV, delimited, and import your point into the software. And the last one, which I just stated now, if peradventure in one of his data, when inputting data, and he puts a comma sign instead of a dot, to destroy the process of importing your points. So those are the 3 challenges you might encounter when importing your points. So let me go back and import the points. I want to import the point to. So I'll import the point to the side. You guys can practice over the week. So the points now. So if I click on import point now, let me import out those 2 points. This is this. So the points. So then when my file is restored, I click open. and I select the format that matches with what I'm bringing in, which is this format here, NZ. So the next point of corner, okay, yeah, Victor, I've imported point, or it's not showing on the screen. What happened? I saved, what do they call it? I followed the basic steps and the basic approach to point importation. And my point is not displayed on the screen. What is happening? That's where that's what normally causes that is you have to ensure that this guy is checked here. Add point to point group. Very important. If you didn't check this and you just click OK, thinking that your point will be displayed on the screen, nothing, you won't see no point. So as I add the point to point group now, I've checked add point. Yeah, Victor, I add point to point group. And I click OK, my point is not showing. What happened? There is one now, this is not coming to play again now. You have to ensure you create a point group for that particular point you're creating. It's like you're creating a layer now for that point. Just like when we work in AutoCAD, we create layers that we can switch and off. So this box you're seeing here now is like you're giving it a layer for that point now. I will now click on this box and do what? And click and give it a layer. Let me say TR1 points group. Point group. Okay, then I'll now click OK. These two things I did now is very, very important. Very important. If you pass all the criteria in your point importation and everything,
Please, can you come again? Come again.
What I say then is, if you've passed all the criteria now, you've met all the, what do they call it, your point importation, you've what do they call it, you've done all those auto processes that your point is not displayed like this on the screen. Everything comes out like this, and everything is okay. And you click OK without checking this box and giving the point group a name. That point won't be displayed on the screen. It's like you're working on a blank layer without attaching a layer. It's like in AutoCAD. Now AutoCAD has a default layer, which is the 0, which all comes out with. You're working to online 0, any layer. If you're working, you're not giving layer, you're working on only 0 layer. If you switch that 0 layer off, everything goes off. But once you segment them into layers, you create a layer for your column, a layer for your wall, layer for your beam, layer for your slab, all these things. You can switch them off and off. That's the same principle Civil does here. So if as I've added this point group, as I'm adding this point to point group, if I didn't check this guy now, I didn't check this, and I click OK, let me just do it so that we see. And I click OK. I've put points, and I do a zoom extend to see my point. Z, enter, E, enter. That point, you can see how it is playing. It is playing blank. This one because I've given it a name. Let me go back and do this thing again. So let me go back and import the point again now. I click on points, import points. What the other display now? I'll click this. I specify this. Then the next point, of course, I said, check this box. Add point to point group must be checked. And I come to then I must give it a name here. I'll click on this box here and create a name for it. Enter the name of the group to be created. TRO1 N1 point group. Or you can give it the project name you're working on. Save it in. Just the project, any name, Victor point group. And I click OK. And I click OK. Watch, I click OK. Once I click OK now, I've done what they call it. I've done, I've checked, I've imported my points. I've checked add to point group. I've given my point group a name, but my point is not still displayed on the screen. That's why you now do a command in AutoCAD called zoom extend. That zoom extend is just, you can type Z on your computer. Just type, click on Z, enter, then E, enter. The point now will be displayed on the screen. So this is the point now. I've now imported the point on my screen now. I've now imported the point screen now. So this is now points. This is how the surveyor went and picked his points on site. So this area you are seeing here, these extensions are the TBM he established on site. Temporary benchmark he established on site when picking. So any question? Any question? Hello?
Hello, Engineer Victor.
Yeah.
Okay, thank you. I think I really enjoyed your presentation, but I think can you still hear me?
Yeah, I'm hearing you, sir.
Okay. I think you have forgotten to show us how to set our coordinates. Where the other time you are talking about UTM, let's say 31N min now, because now we have imported our points now, but it has not been georeferenced to a particular one. I don't know whether you get my point.
Yeah, this data I imported now is your reference already.
But now we have not done the settings for, okay, maybe we are using UTM, maybe the
Okay,
or south.
Or... go back and do settings. If for adventure, even you do the settings, and I understand what you're saying, I can go back and show you how to do settings in Civil 3D as well. But the settings, when we are done with your work, the settings is not that important because this particular thing I'm working on now is already your reference already based on the coordinates he has given to me, based on the datum he used. So for me to check this thing now, whether it's actually your reference now, know that most of us we are using, how would I call it? We're not using the actual software, the licensed software. So there are other tools you can use as well to check for your projection. There's what we call, we know global mapper and then GIS. So if I'm done with this, I can now use it to now export it to global mapper and do a projection on global mapper. Then from there, I'll now take it to a KML file and check on the location I'm working. So to take me to that projection as well. But on the next class, I will show you guys how to do that setting. I will show you how to do the setting from Civil 3D. When you're using a cracked version, I can show you as well how you can do the setting as well. So any question on other questions on the point importation?
Okay. Thank you, Victor. I know this will be kind of strange for some of us, but you don't need to worry. After this class, now we're going to send out the materials on the WhatsApp group. Then I'll send some video. I'll send a 2 hours video of what we are supposed to do next week. I'll send it ahead of time so that some of us can watch it. And we'll come up to speed with the road thing. By next week also, Victor, you give us a step-by-step approach on how to do a road design. There are basically 5 steps. So those 5 steps are what we'll be demonstrating for the next 3 weeks of the class. Like I said, we don't need to worry. Yes, it's there. We'll send it in as the materials. Don't worry. You don't need to worry. It will look complicated to some of us, and some of us have not installed the software. But like I said, this online training requires more work on your side. It requires your passion. It requires your discipline. Ours is to give you a head up. Ours is to bring you up to speed. Ours is to tell you what you should know. Like I always said, that is the best way to learn. Tell me what I should know in this course, and then with commitment and dedication, I can know it all. So we're going to end the class in the next 5 minutes if there's no question. But I'd like us to ask questions for the next 5 minutes. Then we'll end the class. Then Victor, while that question is going on, just send all the materials, convert them to PDF or whatever. Send them to the WhatsApp group. I try looking up for them in my system. I can't find them. Maybe they're in my hard drive. It's still a hard drive. So I'll send the video and then we'll take it up from there. I'll send the video of the next class of cohort 2. The video of cohort 2, day 7. I'll send it, I'll find it now and send it. Then in the next 1 hour, if you have the time, you can sit down and watch it while we end the class so that others can go and do what they have for today. So I think there's no other question. I'll end the class now.
I have a question here.
Go ahead then.
Yes, thank you, sir. From where Victor was talking, although I didn't join from the beginning, the major factor that determine the width of the lane, the road lane, and the road speed. That is what I want to clarify. I want to get a clarification before the end of the class. I know that we can get material and read most of the time. Victor, can you help us with that?
I didn't even get the question.
I said, what's the major factor that are responsible for the width of the lane, the road width?
Okay. It's the design speed.
The design speed.
Design speed and daily traffic.
Okay.
Yes, those are the two major. It's not just about the width of the road. Many other parameters, this is what determine them. Then the major traffic, which is also the function of the axle load, also determines the pavement. When we come to pavement, also determines the pavement.
The thickness, okay.
Yeah. I mean, daily traffic shows you the volume of cars that need to be discharged from a route. So that greatly influences the route. And that in turn determines also whether the type of road it is. The type of road is also another factor. So there's a road classification, which has two different nomenclature. Either you classify a road by who owns the road, or you classify a road by who uses the road. So all these things are all in the highway manual. For me, I will strongly, even though there's a PowerPoint where we have call out the basic information in the highway manual. So we're going to send you that PowerPoint because the highway manual might be too bulky for some people. So by the time you go through those PowerPoints, it will tell you all this. But I know that you can classify roads based on whether they are by who owns the road. Is it a federal road? Is it a state road? And that one is one
or local government.
Or local government. Then you can also classify a road by the function of the road function. Understand? Is it artillery road? Is it rural road? Is it a highway? Is it inter-highway? Is it interstate highway? So these things are all in the highway manual. For me, I think what we basically have done today is to introduce you to the code and the standard of highway, as well as the standard in imputing data inside the AutoCAD software. Because most of the things we'll be doing from next week is just a computer thing. Because the computer software is so robust that you just have to key in. Once you have installed you have inserted your points, it takes stuff from there. Every other thing will be by your mouse. Click of your mouse, setting standard, setting units, until it plots the road for you, plus the cross section, plus the, there's a vertical and there's horizontal. We say horizontal alignment, we say vertical alignment. Those two things, the computer will plot everything for you. So let's digest what we've done for today. Let's not bore you too much. From next week, make sure you have your software installed. And after the class, if you have not installed the software, ask questions so we can help you. All right. So gentlemen, I thank you all. And we need to end this class now, which is exactly 2 hours we started. So let's see you next week and continue with the road section. Thank you.
Thank you, sir.
Thank you very much. Thank you.
Thank you, sir.
Please, if you don't get anything today, don't feel out of place. Like I said, once you go through the manual, you see, you just come up to speed. Thank you.
Okay. Very